Character vectors are valuable data structures that store one or more strings, as you saw earlier in this series. In this tutorial, you will dig a bit deeper in the building blocks of a character vector, namely its members, strings. You will learn what an R string is, how it is defined, and lastly, you will see some of the basic tools R provides you to handle and explore textual data stored in character vectors. So, let's zoom in on strings. A string is a piece of text represented as a sequence of characters, be that letters, numbers, and symbols. Let's have a look at some strings in RStudio. I have written a string here. R gives people the heebie-jeebies. And by pressing enter, R console returns back the same string with its quotes, showing you that it evaluates the string that you gave it correctly, namely as a string. A string, as you can see, is not identified with an actual word. A single string may contain a whole natural language text or even more than one text. What matters for a string to be evaluated as such is that a sequence of one or more letters, numbers, or symbols is enclosed within either double or single quotes that delimit its boundaries. Moreover, the quotation must be done consistently. What does consistently mean in this context, though? It means that when you are creating a string, you need to pay attention to end the string in a consistent manner, with the same type of code you started with. In the string I created a second ago, I chose double quotes to put around the string. So, I use this type of code in both its beginning and end. The same applies to single quotes. If the string started with a single quote as this one, it should end with a single quote. If the string contains quotes in it, as in the case of having quoted words, then the pairs of quotes inside should differ from the ones outside, as here. Let's try to replace the single quotes in the string with double ones and see what happens. In this case, I got an error message that indicates that there is a problem with the sequence of symbols within our string. Let's try to understand why this happens. Following the quotation syntax rule I just mentioned, namely that the type of quotes is a means for marking the start and end boundaries of a string, and that the ones inside should differ from the ones that mark the borders of the string, then the sequence I just wrote consists of two strings, with some symbols in the middle that do not belong to either strings. So, there are two problems here. First, I declare two strings on a single line, and there are also some symbols, the people part, that do not belong to the string and that also do not represent any variable or function and hence cannot be evaluated by R. The same applies if you chose to mark the boundaries of a string with single quotes. Okay, so let's put aside strings for a moment and let's head on to character vectors again. Recall that character vectors are sequences of strings, and you're going to learn some very basic functions, or commands if you like, but I suggest that you get used to the term function instead of command, since that is the right term to use. And these functions you will see will allow you to handle character vectors and take some basic information about them. Let's assume that you would like to get the number of characters of each of the strings within a character vector. Let's further assume that each member of the character vector is a word string, namely a string that corresponds to an English word, followed by punctuation, for example the exclamation mark, as in the following vector that contains as its members the words of the previous string. Notice that I assigned the character vector as a value to the variable sentence. To achieve this, the nchar function is useful. What nchar does is that it takes as its argument a character vector, and for each of its strings, it calculates the number of characters. Then it returns a new vector with the counts of characters of each string on the positions they were in the initial vector. Let's see it in practice. The first position of the new vector is the number 1, the number of characters of the first word R of the vector assigned to the variable sentence. On the second position 5, For the following member of sentence, the verb gives. On the third position, it outputs 3 for the article the, and so on and so forth. With nchar, you can get a good first overview of the vector sentence. Imagine you had a vector with its members being word strings of a whole text. Then, nchar would give you the lengths of all words in a text. This might be considered a valid factor for measuring sentence complexity in terms of both comprehending and skimming through a text. In fact, the number of characters in a text is already considered such a factor by researchers of the field of psycholinguistics. The next crucial step is to see how you could arrive at a character vector with word units as members, such as the vector sentence. This is an important step to know how to do, since if you have a character vector with words as its members, you could employ R to obtain insights from the textual data. So, how do you get from a raw text to a character vector that has word strings as its members? R provides numerous functions from different packages, but to that end I will use here the base R function strsplit. As I mentioned in an earlier video on R packages, functions that belong to base R are considered inbuilt functions, which means that they can be used from the very beginning of any R session and do not belong to an externally installed package. So, the library function does not need to be used. You already learned some other base R functions, and these are the C or the length functions that you saw. Examples of other base R functions that you already learned in previous tutorials are the C function for creating vectors and the length function for getting the size of a vector. Okay, starting with a raw string R gives people the heebie-jeebies, I will first have to assign it to a variable, and here I choose to call it raw.text. The strsplit function takes two arguments. The first argument is the string to be segmented, represented here by the variable raw.text, and the second argument is the segmentation criterion, namely the criterion for splitting a string. I use the empty whitespace character for that. Notice that the whitespace character is surrounded by quotes to signify that it is a string. Keep in mind that even though it signifies the emptiness, it still has length 1. And by using the whitespace character as a segmentation criterion, I mean that the whitespace character is used to mark the boundaries of the members of the new resulting object, or in other words, the places in the string that the new members will be cut. This will become clear to you when you see it in a minute. In order to get the character vector, there is one last step though. strsplit segments strings into sequences of word strings, but does not return a character vector. Instead, it returns a list, signified by the double square brackets. You haven't seen lists yet, and there will be separate videos on lists dealing with how to define and manipulate them, but they won't bother us now. For now, you simply need to know how to convert the list returned from the strsplit function into a character vector that you know. For this, you need to use the unlist function. The unlist function takes a list as its argument, and as its name suggests, it returns a vector. In this case, it takes the returned list of the strsplit function. Recall that in the case of applying a function on the output of another function, you could either do it in a single step by putting the strsplit function within the parentheses of the unlist function, or in two steps, where you first assign the returned list of strsplit to a variable and then put the variable into the parentheses of unlist. I suggest you go the indirect way so that you get used to defining and using variables. Here, the word.list variable is assigned the value of the list returned from the strsplit function, and the word.vector variable stands for the converted character vector. Let's check on word.vector. As you can see, the result is a character vector that consists of word strings. By the way, the process of segmenting a piece of text into a sequence of natural language word strings is also called tokenization. Now you are in a position to use the familiar by now functions for handling character vectors and to get some basic insights of the text. For instance, you can ask for the length of the vector, or in other words, for the length of a text in terms of word units. As you can see, the text consists of 6 words. Or you could ask for all the distinct words of a text with a unique function. Again, the unique words are 6 since no word is repeated. That's it for now, and don't forget to also subscribe to the channel by pressing the relevant button on the video or on channel's homepage, and then, in order to get updates when new videos are released, you need to activate the bell notification that stands on channel's homepage.